they are unsaturated. And what does that mean? They're able to lift to the side a little bit. So everybody get right up on the person next to you. I know. And now go ahead and lay back again so we really get the idea behind it. Go ahead and lay back. I know it's random. Now there's one quality of a phospholipid membrane that we have to embrace, and it's the idea of it being fluid. Remember the fluid mosaic model? Remember that? I'm sure you talked about it in page 2. Fluid mosaic model, sound familiar? Anyone? Fluid mosaic model? Anyone? They can move past each other, but they can move. So everybody move. Everybody wiggle back and forth. This is what we call lateral movement. I know. If everybody does it, nobody looks down, right? So if we wiggle back and forth, everybody wiggle back and forth. We are proving that there is a little bit of lateral movement. Is anybody willing to roll over each other? You can actually switch back and forth. Anyone want to try it? No. Just right over your friend. Yeah, I didn't know if that would be pushing it too far. I didn't know anyone would be willing to do that. So now here's the problem. We have all kinds of charged molecules that we need to allow to pass through a cell membrane. Charged things will not pass through this. Why not? Why won't charged things pass through a bilipid membrane? Huh? Because the bilipid membrane is nonpolar, and charged things are basically polar. They will only be attracted to polar things such as, what's our most famous polar thing? Water. So charged things such as these guys, which are potassium ions, can exist inside of water, but can't exist inside of that guy. So do we have an extracellular and intracellular membrane? I'm sorry, what are the labels that I have there?
Intracellular fluid.
Intracellular fluid.
And interstitial fluid.
Okay, so when we have a bilipid membrane set up, it's going to have 2 structures to it. So here's our phospholipids, right? They're all lined up together. On the top is usually portrayed which one? Which one is portrayed on the top? Extracellular fluid, also known as interstitial fluid, and we're going to label that an IF. I'll leave this up here so you guys can copy it, those of you who don't have access to your notebooks right now. Okay, these guys on the bottom. And here's the thing. A cell is a living thing, of course. It needs to be able to exchange stuff with its external environment. So we have our interstitial fluid up above. We have our ICF, or our intracellular fluid, down below, also known as the cytoplasm of the cell. Questions so far? So we need to label those. We're going to stick those labels right on the floor. I don't care which one goes which way. Go ahead, Jen. You can just do that part. And, okay, which one is that over there? IF, interstitial fluid. So what we're saying is that side over there is the outside of the cell, and this side is labeled intra.
Yeah.
Intracellular. So intercellular is very different from intra. Intra means inside. Intracellular fluid is the inside of the cell. And what I will tell you right now is that these red balls here represent potassium ions. Where do potassium ions exist in greater concentration? Page? Inside the cell. So go ahead and put 3 of them outside of the cell. Go ahead and just throw them over there, but just kind of in the area of the label. And then go ahead and place the rest of these. Ladies, would you grab these ones from here and stick them inside of the cell? So what you'll see then is we have a whole bunch of potassium ions inside of the cell and very few potassium ions outside of the cell. Nope, not inside of the membrane, please. Inside of the cell. Dough! Why won't they exist in between the legs? The legs are fatty acid tails. Why won't they exist there? Potassium ions have a positive charge. and charged things are polar and can't exist inside of nonpolar things? Yes? Questions? Okay. So now what we're going to do is we're going to establish the fact that you have to be able to have a way for that stuff to get through to this side. It exists in greater concentration over there, lesser concentration over here. Basic diffusion will tell you that everything moves randomly, but in a general sense, those things as a population will tend to move to the outside of the cell. So now we're going to place a transmembrane pore inside of the membrane. And you're our transmembrane pore.
Okay.
What is a transmembrane pore? Oh, all the balls have to go over there. All the balls. And we're going to stick you right inside of here. So you guys are going to part ways, like parting of the water here. The middle guys just slide to the side. Nope, other way. There you go. We're going to make a little space here, and we're going to insert our transmembrane pore.
I'm going to lay down.
Yep, right across everybody. It would be best to have,
like this?
Yep, straight through.
Everybody's.
Okay, so now here's our transmembrane pore. It's not a perfect system because, go ahead and stick your head in the towel up above there. What does the root trans mean? Trans means across. So we have let's get one more person in there, one more volunteer. Joe, go ahead and slide all the way up. And he's going to be labeled transmembrane pore. I think what did I say as a label? Transmembrane protein?
No, these are all just fluid.
Oh, okay. Can I have somebody write one more label for me? Write transmembrane protein. And you write it on a big piece of paper. That's fine. Just tear it all out. And we need one more volunteer to go opposite of him.
You might have to go up more.
Sorry, Joe. You can just go ahead and stick it like right across their legs or something like that. Run right from one to the other. So now we have a transmembrane protein that goes between the inside of the cell and the outside of the cell, and this particular transmembrane protein is only allowable for the passage of what? One structure. Potassium ions. And where are they going to go? From the inside to the outside. From the inside where they are more highly concentrated to the outside where they are less concentrated. So Jen and Joe, go ahead and just do your arms like this. Do a circle like this. And that is going to represent our pore. And we have to actually roll the balls, Allie, all the way from Joe's head. The rest of our transmembrane protein, everybody else in the bilipid membrane, you have a job too. You have to keep your lateral movement up. So this is our exciting ending to our tableau. So here, let's have the movement of all the structures. And can we?
You're gonna make him be right.
Roll on down. You gotta get it through. You gotta get it through. That's fine.
Oh no. Wait, your head.
There we go.
I'm sorry. Oh my god.
Are some of those going to come back the other way? Yes. Go ahead and throw one back the other way. Paige, go ahead and throw one the other way. Yes. Nice.
I'm sorry.
Okay, we're done. Thank you very much. Good job, you guys. Okay, take all the labels and put them back on the table there. Gather those up. I think I'll just put them in this little Fisher Price bag.